Companion mode means no audio video, just that controls will be there. Okay. So last class we talked about this meeting getting recorded. So last class we talked about drag force. One different. So do you remember the velocity that we got it as a function of time? Someone's trying to join. So the thing was, so I'll give a recap of the last class thing that we did. Something which is released with, and I don't drag force. This thing we have done in the last class. Drag force is given by minus of kV. So where minus sign indicates that this force will be acting opposite to the velocity. And k is a constant that will be given to us. And basically it is found experimentally, whatever that constant is going to be. And even this drag force formula is something which we found out through experiments only. I hope I'm audible properly, no? Just do. Camera. So at t equals to 0, if I release an object near the surface of the earth, so the force of gravity we know will be mg. Just a second. So if I release an object at t equals to 0 with velocity 0, then only force it is going to have is mg. After some time t, suppose it is having velocity equal to v, and obviously the velocity that he will have will be in downward direction. So due to it having a velocity in downward direction, the drag force will act in upward direction. So what we did, we found out the force total in down direction, which came out to be mg minus kv. Then we wrote it down as force equals ma, which is equal to mg minus kv. So we got a to be equal to g minus k by m into v. So what kind of case it is? A case where I know the acceleration as a function of v. So to find velocity as a function of time, we will be doing the same thing, integration. So we'll write dv by dt is equal to g minus k by m into v. And then we will throw dt to that side. And when I go for integration, we will realize integration of v, we cannot do it with respect to t. So we will do something, we call it as variable separation, in which we are going to keep the terms of v along with dv. So keep terms of v along with dv and terms of t along with dt. So we get dv by g minus k by m into v equals dt. And then we are going to integrate both the sides with proper limits. At t equals to 0, velocity v, at time t, at t equals to 0, velocity v equals to 0. At time t, suppose velocity v is equal to v. Integration of this thing gave us v, which came out to be equal to mg by k into 1 minus e to the power minus kt by m. So we came across a term called terminal velocity. So terminal velocity is the speed or the velocity after long time has elapsed, or after long time, whatever the speed or velocity it requires, that is called as terminal velocity. So in the expression of the velocity, you see the term e power minus kt by m. So if I'm going to use t as infinity, it becomes e power. Okay, I'll make some people admin. Okay, make me an admin. So I have added some people as co-host. So in case if someone is trying to join, I don't see them, you may join them. Okay.
Sir,
So if someone is trying to join in between, you add them. Okay. So
sir,
if
can
I
you hear?
make t to be infinity, when t tends to infinity, what we get? E power minus kt by m is going to be e power minus infinity. And that is 1 by e power infinity. That is 1 by infinity. And that is 0. So what you will find here is that v will be equal to Vt will be equal to mg by k, that we have seen it in the last class. So basically you should know this result like this. V equals Vt into 1 minus e to the power minus of kt by m. I'll tell you just a moment. So just what I did here, this entire bracket g minus k by m into v, I'm keeping it below dv. And that integration of that thing, we have done it in the class. Remember? You want, I can do it again, but check out. Remember, no? So upon simplification, we got that result. This is already done in the class. Just I'm giving a recap of the last class. Understood, no? So this is how you must know this result of velocity. Now the graph of this thing you should know. It's like very famous graph. So one thing is sure that at t equals to 0, if I ask you one more thing, if job here anywhere is to find terminal velocity. So whenever terminal velocity is achieved, the net force acting on the particle will be 0. Or I can even write the acceleration of the particle will be 0. So even I can use this thing directly to find the terminal velocity. So what all forces that are going to act upon him at any moment will be just two. One will be drag force kV upward if it is moving down with V, and another will be mg down kV upward. To have net force 0, what I must do, or to have net force 0 or net acceleration 0, kV must be equal to mg. So when V is equal to mg by k, then net force will be 0. So that will be the terminal speed. Okay. So this is something we have done in the class, and I gave you as homework to draw the graph of this thing. So that I will draw it now. So I hope I can take a new page. You can do like thumbs up in case you can't use my can't type. Okay. Okay, something I can take in page.
Excuse me, sir. Sir, here when we took when like acceleration is equal to 0, how do you get terminal speed, sir, instead of
Can't
terminal?
hear you. I don't know why it's not. I will rejoin back. Okay, just a minute. No. Now I can hear you. But now I was able to hear you. See, when net force 0, obviously net acceleration will be 0.
Hmm.
So net acceleration 0. So you make net force 0. How many force I have? One upward, one downward. How come I can have net force 0? When they are supposed to be of same magnitude, then only they can cancel each other. Direction is like already opposite. Correct, no? So when I will have net force 0, when kV must be equal to mg, so terminal speed will be mg by k.
Sir, so we are not finding terminal velocity.
Speed velocity same thing here. 1D motion, no man.
Hmm.
Particle moving along x with a speed 2. What is velocity? 2. What is the speed? Yes, sir. I'm got the point.
Yes, sir.
Okay. I can take any. Sometimes the speed used to refer velocity also. So you should get the idea.
Sir, but anything after experiencing some drag force will reach zero only, no, sir, as net force.
Net force 0, man. Net force means total force 0, no? Correct?
Yes, sir.
Total force 0 means what? Resultant of mg and kv upwards should be 0.
Okay, sir.
So two case I can have net force 0. One case no force acting. Another case force is acting, but they cancel out. Correct? So force 0 and totally force 0. Obviously force will be acting, mg will be acting. I'm taking net force 0. Clear, no?
Yes, sir.
The graph of this thing, if you draw it, so there is the graph that should remember. V equals mg by k into 1 minus e to the power minus kt by n. So do one thing, find the differentiation, find the differentiation of v. So differentiation of v will be, what will v is mg by k into minus of mg by k into e to the power minus kt by n. So if you have trouble with differentiation, I will do it. Can you find the differentiation of e to the power minus kt by m with respect to t? So what formula you will use in case if you forgot chain rule? Differentiation of e to the power ax plus b with respect to x was a into e to the power ax plus b. I hope I'm audible, no? So it is not good. But I hope all of you can understand me. So the coefficient of variable term here is minus k by m. So its differentiation will be minus k by m into e to the power minus kt by m. So you do the differentiation, it will be dv by dt will be differentiation of mg by k, which is constant, minus the differentiation of mg by k into e to the power minus kt by m. So this is 0. Mg by k constant will be taken outside the differentiation operator. So we get minus mg by k into dy by dt of e to the power minus kt by m. And differentiation of that we know. So minus mg by k into minus of k by m into e to the power minus kt by m. So you see minus plus kk gone, gone. So the acceleration is g into e to the power minus kt by m. So again, we will draw the graph of this one also and this one also. So what we have is, you check out. So now you think like it's a mass function whose graph I have to draw. To determine the shape of the graph, I must find the double differentiation. So first differentiation we know it came out to be g into e power minus kt by m. And tell me, is it not a quantity which is always positive? Correct, no? Always positive or not? So it is always positive. Always positive means what kind of function nature will be? Always increasing, no? So think of v as a function of time or v as a function of variable t, whose differentiation is always positive. So it is going to be always increasing. Now find its second differentiation just to determine the shape of the graph. I'm doing all this so that doing all this will help you remember the graph. So again, I differentiate it. It's going to be double differentiation of v. That will be dy by dt of g into e to the power minus kt by m. So g, I will take it outside into differentiation of e power minus kt by m. Differentiation of e power minus kt by m, we know it is this. So we will get minus of kg by m into e power minus kt by m. So you see e power anything negative or positive, whatever, e power minus kt by m, someone is trying to join. So I have made some people co-host now. So in case if someone is trying to join, please join them. Okay. So e power minus kt by m is a quantity always positive. So minus of that will be always negative. So always negative means the shape will be always concave down, correct? So how much things I have? One thing is the shape of the curve will be always increasing. Sorry, the trend of the curve will be always increasing. Shape of the curve will be always concave down. And few more points I will find. At t equals to 0, if I plug t0, and I know also even, I'll get 1 minus e to the power 0. Let's check out whether our answer correct or not. mg by k into 1 minus e to the power 0. So that will be mg by k into 1 minus 1. That will be 0. And one more point I know, after long time, when t tends to infinity, v becomes mg by k. By this much data in our hand, I will draw the graph. You tell me correct or not. I can take a new page. How we are getting, that is something you want me to tell that we have done in the class. Okay, if you want, I can do that thing. No problem. So we have dv by g minus k by m into v equals dt. Here limits is from 0 to t. Here limit is from 0 to v. And what formula you will be using? But the dx by b plus ax is by right. that will be 1 by a into log of ax plus b. So it's going to be log of g minus k by m into v by minus k by m. Lower limit 0, upper limit t, sorry, what t, upper limit v. Left side integration, that will be t. So plugging the upper limit will get minus m by k log of g minus k by m into v. This is the upper limit value. Lower limit will be plug 0, that will be minus m by k log g equals t. We'll write the positive term first. We'll get m by k log g minus of m by k log g minus k by m into v equals t. So we get log g minus log g minus k by m into v equals t. So log g by g minus k by m into v. I've thrown m by k to other side, it will become kt by m, no? So that is going to be equal to kt by m. What log here really I have? Log whose base is e, no? So here I have a log whose base is e. So now we'll use that result. That log 39 was what? 2. We can write 3 square as 9. So same thing I will do here. E to the power kt by m will be equal to g by g minus k by m into v. So simplifying it, we'll get g minus k by m into v is going to be g by e to the power kt by m. That I can write down as g minus k by m into v equals g into e to the power minus kt by m. So g minus g into e power minus kt by m is equal to kv by m. Take g common, so we get kv by m equals g into 1 minus e to the power kt by m. So v equals mg by k into 1 minus e to the power minus kt by m. So I hope this all things are clear, no? I'm going to share the PDF of this thing. So you can copy it later on also. And this was done in the class already. Okay, then now, so we will plot the graph of this function. And you should remember this graph forever. After a long time, the velocity will become equal to mg by k. And that is something we call it as terminal velocity. Graph of this thing always increases, starts from 0, shape concave down, and will become equal to mg by k after long time, no? So what is the plot of v versus t will be? It's going to be this. So it is going to touch that line, but at infinity. So this is the plot of v equals mg by k into 1 minus e to the power minus kt by m will be. Okay, I hope this thing is clear. Next, I will draw the graph of acceleration also. So this is a kind of graph, what really I can call it as exponentially increasing, no? So you can tell what is the nature of this graph is always increasing, you see. Then what is the shape it has everywhere? Concave down. And this line, blue line, is tangent to the curve, but at infinity, correct? Because when this graph is going to get to the value mg by k, there it will touch that line. But when? At infinity. So this line is tangent at infinity. In maths, that is given a name, asymptote. Asymptote. So this, if I ask you what is the equation of this line is, so on y-axis we are plotting v. So v equals mg by k is the equation of the line, and this is the asymptote of this graph. I can take a new page. I can take a new page now. Okay, then. Next thing is the acceleration. The acceleration came out to be g into e to the power minus kt by m. Now, if I differentiate e power minus kt by m once, it becomes negative. So first differentiation of this function is going to be always negative, you can check. Second differentiation of this function will come always positive, you can check. Always negative means always decreasing. Downward arrow means decreasing. Always positive means the always it is going to have the shape which is concave up. At t equals to 0, you find out its value. We know also at t equals to 0, the acceleration it has is g because drag force is 0 at t equals to 0. So at t equals to 0, you find that value even from this g into e power 0, which is g. Find the acceleration after long time. We know after long time, it achieves a constant velocity. So acceleration will be 0, and it's 0 only. A will be g into e power minus infinity, which is 0. So what really happens here is that the starting acceleration is g. Then it decreases, and after long time, it becomes equals to 0. So A versus T plot I have to draw. So it is going to be like this. At T equals to 0, acceleration is g. And after long time, it's going to touch this horizontal axis when t will be infinity. So here, this horizontal axis is the asymptote. And it is an example of exponentially decreasing function. So these two graphs you should remember always. Okay. Copy this thing everything fast. If you are copying. Now we will solve that question number 6 of exercise 2. Okay, I'll wait.
Sir, I have a doubt.
Tell me, yes.
Sir, in the terminal velocity, you wrote t equals to infinity, t reaches infinity.
Yeah, it is the velocity when t is infinity.
So that is known as terminal velocity.
Yeah, terminal velocity. And after long time, and the velocity it is going to have this much. And what is that velocity is constant or not? So you can check acceleration came, what it came, where I wrote that one. Here is the acceleration. See, acceleration is this much. After long time, what is the acceleration? It is going to have 0. Correct?
Yes.
So acceleration 0 means force 0 means terminal velocity whenever we achieve. Net force will be 0. So what we can do? We can make net force 0 if job is to find terminal velocity only. Correct?
Okay.
Or else you can find v as a function of time. After finding it out, you plug t as infinity. That too will give you same answer. But that is a logical thing. You tell me, at the t equals to 0, what is the drag forces? Something 0, no?
Yes, sir.
At t equals to 0, our drag force Fd is 0. mg always constant, no?
Yes, sir.
After some time, if I ask you, what will be the drag force? It will be something. And if velocity is v down, the drag force will be kv upward. Now, as time passes, what happens to the mg? Mg remains constant. And what happens to the kv? Kv increases. And kv increases gradually, no? Suppose mg value is 60 and kv keeps on increasing. Don't you think there will come a time when kv will become equal to mg?
Yes, sir.
So whenever kv becomes equal to mg, what is the net force it will have? 0. What is the net acceleration it will have? 0. So what is the speed it will have? Constant. Correct. I hope clear, no? So at terminal speed, whenever we achieve that, net force will be 0. So just making net force 0 is enough to find terminal velocity. I don't require finding v as a function of time. Find terminal velocity. Clear, no?
Yes, sir.
Okay. So this graph also, I hope all of you will remember. And this graph also, all of you will remember. This kind of graph you will be seeing in chemistry also. Many times you will be seeing it in physics. It's not like you can forget this thing. You will forget again, you will see. You will forget again, you will see. So many times you will see this graph, you can't forget also, even if you want to. So this thing clear, no? Starts from G and then decreases. And after long time becomes 0. So how we draw that thing like this, showing that it is tending to touch the x-axis or t-axis after long time. Clear, no? Easy or difficult, clear, no? And I can take a new page. I can take a new page. Okay. I'm going to save this PDF also, copy it afterwards in your notes. We'll take a new page. V is mg by k. Yeah, correct. Acceleration becomes 0. Yeah, correct. Force 0 total means acceleration 0, no? Yeah, correct. So maybe make acceleration 0 or force 0, both same thing only. Okay. Next thing is that question. So see, is it not same like earlier one? Earlier one, if I write, what was the thing that we had there was dv by dt is equal to g, which is a constant, k by m, which is a constant, into v. Instead of that, what really given to you is, instead of g 6 given, instead of k by m 3 given. So same thing or different thing? Same thing. Now check out one thing. Option C and D, you can solve it without solving anything. So they have told us that at t equals to 0, the particle was at rest. And they have told us the acceleration in terms of v. So now they're asking us find the magnitude of initial acceleration. It's like they're checking whether we know English or not, correct? Because they have told us a is 6 minus 3v and the velocity at t equals to 0 is 0. So what is the acceleration at t equals to 0 will be 6 minus 3 into 0. So the initial acceleration, which means acceleration at t equals to 0, is how much? 6. So the magnitude of the initial acceleration is 2. That is wrong. So option C, you can solve it without solving anything. Correct? Now, option D also is like that. The speed is 1 meters per second when the acceleration is half the initial value. So when A is half the initial value, means what? Suppose initial acceleration, I call it as A naught. So when A is A naught by 2, which means A is 6 by 2, which is 3. So again, I will use A equals 6 minus 3V. So 3 equals 6 minus 3V. So we get how much? 3V equals 3. So V equals 1 meters per second. So option D is correct. Now next thing is speed is always increasing. So it is same, literally same case. Is it not? So what is happening to the speed without solving? If you remember this thing, totally you can tell speed increasing. So only thing left is to solve V as a function of time. So do you want me to solve or you try once? I'll give you 2-3 minutes to try everything. Okay, all of you try. So same thing you do, separate the variables. Maybe I'll start it for you. So dv equals 6 minus 3v into dt. So dv by 6 minus 3v equals dt. And you will be integrating it with limits given at t equals to 0, the velocity is 0. And let's assume at t, the velocity is v. So please do this integration, everyone. T equals to 0, how acceleration is 0, you're asking, no? So it is told here, is given at t equals to 0, the body was at rest. So we know acceleration in terms of velocity, and at t equals to 0, velocity is 0. So put v 0, what a becomes? 6.
Sir, but the acceleration which you got is 6 meter per second square.
Yes,
Even
so
if there is acceleration, the velocity can be 0.
why not? When I throw a projectile vertically upward at maximum height, what is the velocity is?
0.
What is the acceleration is?
Minus g.
There, no? So
Yes.
acceleration there, not there, it has to do with force.
Hmm.
You're moving, you're not moving, who cares about that? Force acting, acceleration there.
Oh, okay.
Whether object is moving or not moving, that does not decide whether there is some force acting on him or
Hmm.
you are moving on earth or not moving on earth. Who
Okay,
cares?
sir.
Earth will be pulling you or but it
Yes, sir. Understood.
so solve V everyone first man. Anyone got the answer? Or you want me to solve? You should try one. That much practice you should have. Yeah, correct. Option B correct. Yeah. The same like old case, just instead of G, I have 6. Instead of K by M, I have 3. So obviously option B correct. Speed is increasing. Yeah. Infinity never reaches, no? It's a concept. So infinity literally we never reach. And dv by dt is always positive. So speed always increases. Option B is correct here.
So I couldn't understand. Can you repeat why the speed is always increasing?
So let's check out that one. So tell me, this is the graph. Everywhere slope positive or not? Forget about infinity. No one's talking about infinity. Before infinity, at every point, anywhere I drop a tangent, you will see the angle made will be acute, will never be acute. So dy by dx always positive means what kind of function it is? Always increasing. And what is the differentiation of E king? Always positive. Correct?
Yes,
Correct? Always positive. So don't worry about what happens at infinity before that. Before that, always increasing, always. Clear, no? Correct?
yes, sir.
So I hope all of you got that. Option A also correct. At infinity, speed is constant, but in infinity, when it is reached, never. Correct.
Sir,
we
so
don't-
option B is correct.
Option B is correct. Yes. So except infinity, I must be looking. Because
Sir, but
infinity, yeah, when
yes,
it,
sir, but when it reaches infinity, it becomes constant, right?
Yeah, but infinity it never reaches technically, correct?
Yes, sir.
So, so till that, what happens? They are asking us. It increases.
Okay, sir.
Correct? No? You should
Hmm.
know.
Yes, sir.
I will solve it if you did not got it. So we have dv by 6 minus 3v equals dt 0 to t 0 to v. So integration of this thing will be log 6 minus 3v divided by minus 3 0 to v. Other side integration is that will be t. Plug the upper limit, it becomes log 6 minus 3v. It becomes minus of log 6 minus 3v by, that is the upper limit value. Lower limit value will be log 6 minus of log 6 by 3 equals t. So it will become log 6 minus log 6 minus 3v. 3 I have thrown to that side equals 3t. So log 6 by 6 minus 3v is equal to 3t. So we have log base is e, no? So we get 6 by 6 minus 3v equals e power 3t. So we get 6 by power 3t equals 6 minus 3v. So we get 6 into e power minus 3t equals 6 minus 3v. So 3v equals 6 minus 6 into e power minus 3t. So v equals 6 by 2 into 1 minus e to the power minus 3t. So v equals, sorry, 6 by 3, no? Okay. 6 by 3, which is 2. So 2 into 1 minus e to the power. Okay. So what is dv by dt will be? dv by dt is the differentiation of v, that will be 6 into e power minus 3. So tell me, is it not always positive? So what it means? Always increasing. If rate of change always positive means always increasing. Clear, no? Clear enough? Other in fast fast. Copy fast, man. One question we have only done. Little thing is don't copy. After the class, you try to solve it on your own. If you're unable to solve it, then you check the PDF that I will share with you. And I will take a new page. Before I give you a question, in case if you have forgotten, I will ask something first. Velocity versus, not velocity versus, acceleration versus x plot given of a particle moving along x direction. So a particle undergoes 1D motion and its acceleration versus x plot is given. Okay, a part of it given. So can you find a as a function of x given? Here the value of the A is maybe 10. Here value of the X is suppose 5. So can we find A as a function of X? I hope you remember that slope intercept form. So if I give you a straight line whose x-intercept and y-intercept I know. So how much is the x-intercept this line has got? 5. How much is the y-intercept this line has got? 10. So what was that equation of the line? X by A plus y by B is equal to 1. Or in case you don't remember it, still, at least you should remember that first one, no? Y minus y1 equals m into x minus x1. Whatever way, you can find the equation of the line. So here I have, instead of y, I have a. What is the y-intercept is? Y-intercept is 10. So a by 10. X-intercept is how much? 5. So x by 5 is equal to 0. So what will be our a? So a by 10 so equal to 1. So what will be our a? A will be 10 into 1 minus x by 5. So a equals 10 into 2x. So what kind of acceleration here we have? Something like this. Correct? So purpose is in case if y given, forget about acceleration. If y given and x given, you can write the equation of the line. Y by 10 plus x by 5 equals to 1. Correct? So you solve this question. Will even try this question? A versus V plot given, and from that we have to find V versus T plot. Module they gave B is wrong in that question. Change the answer. Yeah. Change the answer. So speed is always increasing is correct. Option B is correct, A is correct, and D is correct. A, B, D is correct. Okay. A, B, D is correct. So maybe in your module, you add one more option. You write option E. Terminal speed is equal to 2. Correct or not? Whenever terminal speed is achieved, acceleration will be 0. So I will make A 0. So what V is equal to 2. Or even we got V equals 2 into 1 minus to the power minus 3t. So what is the velocity we have when t is infinity? It is going to be 2 only. So this option was there in the old module. Okay. They removed the option B with this thing. In old module, I can show you terminal speed was asked. So you add option E on your own. You should know how to find terminal speed. You should not forget. Now try this question, everyone. Let's see who can answer it. A versus V plot given. Just now I told you, if y-intercept, x-intercept given, then what we can do to find the equation here. So A versus V is a straight line. We can find the equation of the straight line in terms of A and V. And what kind of equation you get? Is it not same like
Sir, is it
6,
option D?
Yeah, option D. Yeah, correct. Correct, no?
Yes,
Suppose
sir.
if that question was not done, then option D will be so headache or not? Correct.
Mm.
So what I will do here, A is equal to, so it will have something here. Suppose it is maybe 10. Suppose this is 5. Some constant thing only, no? So A by 10 plus V by 5 is equal to 1. So A equals 10 into 1 minus V by 5. So A will be equal to 10 minus 2. So it is same like old form. Correct? So A equals 10 minus 10 minus 2V. Same like earlier, the graph will be exponentially increasing graph, not like a straight line, not a parabola. Obviously not like this. It has to increase, and then it is supposed to become like constant. So option D is correct here, no?
Yes, sir.
Correct. Now you will try question
Sir, can
9.
you tell how you got those values 10 and 5 for that question?
So 10 and 5, I'm just assuming, suppose not 10 and 5, some other constant, if that 10 and 5 is confusing you. Suppose this is something V naught constant, and this is A naught. What is the coordinate here will be, Johnny? Here coordinate will be 0 minus 0 comma A naught. Here coordinate is how much? V naught comma 0. So x-intercept is V naught, so V by V naught. Y-intercept is A naught, so A by A naught equals 1. So find A from it. So A equals 1 A naught into 1 minus V by V naught. So A equals A naught minus A naught by V naught to, so what really it is, earlier case was A equals 6 minus 3V. Earlier case was A equals G minus K by M into V. Is it not same? Instead of G constant, I have A naught. Instead of K by M, I have A naught by V. Same kind of function, same kind of
Okay,
V.
sir.
So exponentially increasing. That's why I told you, remember that perhaps. Okay, this question came in exam of in the elite batch, recent exam of elite batch. Clear, no? Clear, no? Now you will try question number 9. Particle moves with initial velocity v naught and retardation beta into v. Where v is the velocity at any time t, beta is a positive constant. So they are asking us the total distance it covers and few other things. So maybe you find out velocity as a function of time. So retardation, it is 1D motion, plus minus will be used for direction.
So is retardation negative acceleration?
Yeah, correct. That is what I will write. So suppose the velocity direction, I take it as positive. And it is told it is having, suppose initial velocity in plus x direction. U is v naught. So acceleration will be opposite, beta v. So with sign convention, if I write us plus v naught, Then acceleration in direction opposite to that, the minus of beta. So it is also a case when you know acceleration as a function of velocity. So what is the thing given? A is equal to minus of beta into V. So we will write V as A as dV by dt. And then we will separate variables to do the integration. Because at t equals to 0, I know the velocity. So to do integration, I will throw dt to that side. So dv equals minus beta v into dt. So as you can tell, to integrate it, I must keep terms of v along with dv. So we will do that variable separation. And then we will write dv by v equals minus of beta dt. And then we are going to integrate it. So everyone please do the integration and try to find the values, try to find v. So I'll write the limits also. At t equals to 0, velocity v naught. At time t, velocity v. Just a moment. So you must remember this two curve. Y equals, if I give you a constant, into 1 minus e to the power minus bx, where a and b are positive constant. Then the graph of this one I will draw, and you should know it forever. So when x tends to infinity, what is y is becoming equal to a. So you draw the line y equals a, and y equals 3, 5 some constant. That line is parallel to the x-axis. So graph of this function is like this. So this is one standard graph you should know. Another standard graph you should know, if I give you y equals a into e to the power minus bx. And again here, a and b are positive constant. So here at x0, what is the y is? A. And when x infinity, what is the y is? 0.
0.
This graph also you should remember. Okay. These are like so common that not forget. In chemistry also this is so common. So now what we have here is dv by v will be what? Log v, direct formula, no? Log v.
Yes, sir. Log v minus log v naught.
Yeah, correct. And that side, beta coming outside, integration of dt, just dt, 0 to t will be.
Sir.
So log v minus log v naught is equal to minus of beta t. So log v by v naught is equal to how much? Minus beta t.
Beta. Sorry,
Yeah.
minus bt.
So log, what log it is? E. So what I will do next, that log formula, I will put RHS things in power of E. So we get V by V naught equals E to the power minus beta t. So what E becomes, so we get V equals V naught into E to the power minus beta t. Now tell me, what is this graph looks like? Exponentially decreasing or not? Correct me? y equals a into e power minus bx. When x tends to infinity, what y becomes? Tends to 0. And when x is equal to 0, what
Y is
y is
equal to
equal to
A.
2. So same kind of graph or not? Correct.
Yes, sir.
So if I ask you, how long this particle will be traveling till it is not getting speed 0. But when speed will be 0, when t is infinity. Correct. So when t is infinity, or that is not written, we write t tending to infinity, what v tends to 0.
Yes, sir.
Means till eternity it will keep on moving. So if I ask you find total distance covered, means you find the distance covered till it moves. Correct? But what to do for that? So copy this part. We will discuss that in next page. Clear now? This thing clear? So when the speed is going to become 0 after long time, so do you think the particle will stop throttling? No, stop throttling means while it was moving in between, sometime it came to rest. Like if I throw a projectile vertically upward, at maximum height for a moment, it will come to rest. So such kind of thing not happening. So option C guaranteed 0. So option E we will check next.
Sir,
The
option
velocity,
B correct, no, sir.
option C wrong. No,
Option
option
B
B,
correct.
option B correct. So how long it travel? For long time. Definitely long time. So option B correct. Option C wrong. The velocity of the particle will become v naught by 2 after time 1 by beta. Let's check. So function of v we know. So we have to find the time when it is going to become v naught by 2. So what we have is log v by v naught is equal to minus of beta t. So what we get is log v is v naught by 2 by v naught. It is equal to minus of beta. So it is going to be log 1 by 2, that is minus of beta t. Correct. So log 1 by 2 is same as log 1 minus log 2. That is equal to minus of beta into t. Log 1 is 0. So minus log 2 equals minus of. No. Those things will not be there in our test. Don't worry. Up to rectilinear motion only without graph. But our graph will be over by this Sunday. Okay. Everything will be over. But up to beginner box 3, you have to prepare. Okay. And graph thing you will not need to prepare. It's easy. Okay. So what we get, t is equal to log 2 by beta, not 1 by beta. Correct. So velocity of this, so option D is. Now option A I have to check. So tell me, particle starts from origin and always moves along positive x. So what is the distance and displacement is same? Correct? Correct or not?
Yes, sir.
Copy this thing. I'll take a new page.
So before that, can you explain option D's calculation once more? I didn't understand.
So nothing there. V by V naught. V is V naught by 2. So V naught by 2 by V naught. What it became? 1 by 2. So log A by B will be what? Log A minus log B. Correct? So log 1 by 2 will be what?
Yes, sir.
Log 1 minus log 2. Log 1 always 0. Or not?
Yes, sir.
So what it became? Minus log 2 equals minus beta t. So what is t is? Log 2 by beta, correct?
Yes, sir.
So what answer they are telling us t is 1 by beta? Wrong, no?
Yes, sir.
Got it.
Sir, instead, can we substitute in the original equation which we got, like V equals V naught?
Yeah, that too we can do.
Minus-
V equals, yeah, correct. V naught into e power minus beta
One
into
by
1 by beta. So V is V naught by E, not V naught by 2, wrong. So that's why option D is wrong, correct? No.
yes.
Whatever way, both are correct.
Okay, sir.
Clear, no? That's now and correct. Okay, then let's see what to do for the next case. So if I have to find displacement in a some time interval, so we write V as dx by dt, or suppose velocity given to you as a function of time, we write dx by dt is equal to the velocity given to us as some function of time. So dx is equal to velocity into dt. So if I integrate it in the next step, if I integrate it from t1 when position was x1, t2 when position is x2. So what is the left side integral will be x limit x1 per limit x2. That is same as integral of the velocity function from t1 to t2. So left hand side will be x2 minus x1. And what x2 minus x1 is? Displacement. So for whatever interval I need displacement, for that much interval, for that much time interval, I will find the integration of the velocity function, correct? Suppose if I take a case, particle starts from suppose x equals to 0, or maybe from any place, and always moves in positive direction. Velocity always positive. After some time reaches x equals to 10. I ask you, maybe starting from not 0, also suppose starting from x equals to 3. Now if I ask you what is the displacement is 10 minus 3, which is 7. If I ask you what is the distance is, also 7, no? So if I have unidirectional motion, if motion is unidirectional, means no change in direction, then magnitude of displacement is same as distance covered or not? This point clear, no, everyone? Even though motion happening in minus x direction, suppose was particle moving this way, at some point of time it was at x equals to 10, after some time reaches x equals to 3. This side I took it as positive, motion happening in negative direction. So change in position will be final 3, initial 10, minus 7. So displacement is minus 7. How much is the distance? 7. So in case of unidirectional motion, when I don't change the direction, the length of the displacement vector is same as the distance covered or not. Correct? Correct, no? Correct, no?
Yes, sir.
Okay. So I'll take a new page. So velocity is coming out to be v naught into e power minus beta t. So how long the particle travels, like till infinity. So we have to find the displacement up to infinity. Then you will think, man, particle moving till infinity. So it will get infinite displacement. True or untrue? Sum of infinite terms of a series always infinite. No.
No, sir. Depends.
Depends, not same way here. It depends. integration up to infinity can come infinity, can come something. I have to do the integration, then only I can tell. We should not be coming to any conclusion before solving it. So what is the job is to find displacement up till infinity. So we will integrate the velocity function from 0 to infinity. So I will write dx by dt to be equal to the velocity function given to us as a function of time. So dx equals v naught into e power minus beta t into dt. Now to find displacement from t equals to 0 to t equals to infinity, I will be doing the integration from 0 to infinity. So t equals to 0, suppose his position was x naught. Finally, after a long time, its position is suppose x final. That will be equal to, Siri is so stupid now, v naught into e power minus beta t into dt. From where to where I'll integrate? At 0, his position suppose x naught. At t equals infinity, suppose his position x final. Left side integration will be x, lower limit x naught, upper limit xf. So xf minus x naught is the total displacement, and that is equal to integration of this thing from 0 to infinity. And I hope everyone can do and see the Siri can coming up. Siri was a guy, I will beat him up. Going to his home. Like so much stupidities. So V
Sir,
naught, I can take it outside.
constant, sir.
Ah, yeah, V naught constant, no man. Obviously constant, no? Initial velocity. So mine, is it changing with time? No. So integration of this thing, I hope all of you can do it now. So it was the integration of e power ax plus b with respect to x. It was e power ax plus b divided by a. Correct. Same way here, I will perform the integration of this one. So total displacement will be integral of v naught into e power minus beta t dt 0 to infinity. So v naught integration of e power minus beta t will be e power minus beta t divided by minus beta, lower limit 0, upper limit infinity. So I will use upper limit first. That will give us e power minus infinity by minus beta.
That is 0, sir.
That is 0, yeah, correct. Lower limit will be e power 0 by minus beta. So upper limit value, I hope everyone can see that. That is 0. And here minus and this minus plus it will become. And e power 0 is going to be how much? E power 0 will be 1. So it's going to be v naught into e power 0, which is 1 by beta. So even though it moves till infinity, till the time which is infinity, what is the total distance it covers? V naught by beta. Clear, no? Tell me where was physics in this question? Not difficult, no, little bit calculative. Not difficult, new kind of calculation. It is log, no, correct. But clear, no, and everyone.
Yes, sir.
Then, so please try exercise. So by next class, please try all the questions of exercise 1 and 2 and 3, whichever question do not contains a photo or graph. Okay. We will discuss the questions in the class, then we will do graphs of motion. So one more class, your syllabus, whole rectilinear motion. This chapter will be over. But up to without graph, everything before that, consider in your syllabus. Maybe less than that is there in your syllabus. But if I will tell less, you will do less. That is not good. Okay. So you think without graphs, everything you should do. But I will suggest you complete everything before the test, whatever may be the syllabus. Okay. So your module must be done with before the test, man. If you're not solving the module before the test, you're not giving up your fullest. Okay. So we'll end the class. I will share this PDF. Extra class weekend is 1, date is 22 June 2026. Okay, then bye everyone. Thank you for coming in extra class. Bye.
Thank you, sir.
Okay, I'll end the class. Bye everyone. I've sent the PDF in our group. You can check out. Okay, I've shared the PDF in our group. You can check it out. Well, then, bye bye.